let's take a look at a couple more examples. Let's do a cosine function. So let's suppose we have y equals 4 cosine 2x plus 2 pi over 3, and we want to graph this function. We saw a sine graph in the last video. The cosine graph is going to work very similarly, but before you begin, you want to get an idea again of what a cycle of a cosine graph looks like. So if you think about the basic y equals cosine x, that's going to start, remember, you just kind of do a quick little sketch and visual of it. So it starts at the max, then there's an intercept, a minimum, an intercept, and a max. All right, so the positive cosine graph is going to start and end on your max value. You need to keep that in mind as we go through. So just like we did before, start with your amplitude. We still have a positive function, so amplitude is simply 4. That just means when we do our max and our min, we're going to go up to positive 4 for the y value and down to negative 4. Next thing, as I did before, is period. Well, just like the sine graph, the cosine graph has a period of 2 pi. So to look at the period of this graph, we take 2 pi and divide, again, by that b value. So we have a period of pi. So start to end will be pi. Phase shift. So where's the initial value of this graph shifting to? So remember, the initial value of y equals cosine x is at 0, 1. So where's it going to shift to? Well, let's figure that out. Just like with sine, we do c over b. Be very careful. My original function, this is a minus. Here we have a plus. So technically we are subtracting negative 2 pi over 3. So your c value is negative 2 pi over 3, not positive. Divide by b, which is 2. Let's simplify that a little bit. So negative 2 pi over 3 divided by 2 is the same as multiplying by a half. So think of it this way, because you don't want to get this math wrong when you're taking your test. So divided by 2 is multiplication of 1 over 2. 2's cancel away. You have negative pi over 3. So we have a phase shift of negative pi over 3. So that means we're going to the left, pi over 3. Now remember what I said before. When you do get your period, you really need to break up and calculate what is the distance between our key values being our max, intercepts, and mins. But you get that by taking your period and dividing by 4. Well, simply pi over 4. And this again is the distance between key points. Max, mins, and intercepts. Really going to be helpful. So let's start. Well, our positive cosine graph starts the max, then has an intercept, then has a minimum value, an intercept, and ends again on a max. Keeping in mind, this is not your complete graph. This is just one cycle. So we start where our phase shift is. Oh, negative pi over 3. It's going to be our x value. Pay attention to your amplitude. We're not going to 1 in this case. We're going to 4. Now, for your intercept. Well, you have that starting point of negative pi over 3. We got to add a quarter pi to that. So get your common denominator of 12. And you got negative 4 pi over 3 over 12 plus 3 pi over 12. It's going to give you negative pi over 12. And it's an intercept, so of course the y value is 0. For our min value, You have negative pi over 12. We're going to add another pi over 4. So change your pi over 4 to 3 pi over 12 minus pi over 12. It's going to give you 2 pi over 12, which of course is pi over 6. It's a minimum value. So if our amplitude is 4, this of course is going to be negative 4. For our next intercept, well, we have pi over 6, and we are once again going to add pi over 4. Well, pi over 6, of course, we know is 2 pi over 12. Pi over 4 is 3 pi over 12. So 2 and 3. That's going to give me 5 pi over 12. And it's an intercept, so the y is 0. 5 pi over 12 plus an additional pi over 4. Well, we're adding actually 3 pi over 12 to 5 pi over 12. It's 8 pi over 12. Always put it in reduced form. 3 pi over 2. And it's a max value, so it's a 4. So the distance between negative pi over 3 and 3 pi over 2, if we did all this math correct, should be pi. And hopefully, many of you have already seen I might have made a mistake, but that's okay, because this is why we do our check. When you do your check, you know you have negative pi over 3. When you add pi to it, well, what do we get? Don't just assume you get 3 pi over 2. So we have negative pi over 3 plus 3 pi over 3. You get 2 pi over 3. Not what I have. I have 3 pi over 2. This is why you do checks. So now you need to look at where was that mistake made. Well, come over here to your fraction. 8 pi over 12, when you reduce, when you divide by 4, is 2 pi over 3. So you can make simple mistakes, but if you do that check, you'll catch them. And that is why we have these nice little checks. And it makes sense, because the period between the initial part of the cycle and the end part of the cycle we found was supposed to be pi. And it allowed us to catch a simple arithmetic mistake. Now that you have your points, it's just a matter of getting them on the graph. Be sure to label everything correctly. Remember, you're going to 4, down to negative 4, and we're starting at negative pi over 3, pi over 6, and 2 pi over 3. And you're doing a cosine graph, so you might want to just put your dots in first. And there you got your graph. I know I missed the dots, but you get the idea. Okay. Let's take a look at negative. And sometimes you don't have all those values in there that you need to worry about. So we'll stick with another cosine graph. Let's do cosine y equals negative 3 cosine of pi over 2x. All right. Notice you do not have a c value in this case, but let's start with our amplitude. Amplitude is always a positive value. It's a distance. So our amplitude is the absolute value of negative 3, which is 3. But we need to talk about that negative for a second. So we know our basic cosine graph. Again, we just did it. kind of has that kind of, right, look to one cycle. How does that change when we do negative? So again, as you're going through this, you should be playing around with Desmos, because in Desmos, I had asked you before, in the last video, to plug in a negative and see what happens. So hopefully you recall that negative, again, putting a negative in front of the graph will flip it across the x-axis. So basically, it now looks like this. Well, that's important, because we're no longer starting with a max value, right? We have a min, we have intercept, then a max, intercept, min. So you want to keep that in mind and pay close attention to those signs out front of your trig function. Okay, let's move on to our period. So we have 2 pi, because men, sine and cosine, or always start with 2 pi, divided by that b value. That b value, of course, is just simply pi over 2. So remember what I said before, divided by pi over 2 is multiplication of the reciprocal of pi over 2, which is 2 over pi. All those pi's are going to cancel away, and that's going to give you a period of 4. Well, to find our key points, remember what I said, to get that distance between them, take your period and divide by 4. Well, 4 over 4 is simply 1. So there's a distance of 1 between each of those key points. Well, phase shift, well, guess what? If there is no c value, there is no phase shift. Because if your phase shift is c over b, c ultimately here is 0. 0 divided by anything is 0. So phase shift is none. There is no phase shift on this particular graph. So let's get our points down. What you need to remember for this graph is you are dealing with a negative value, negative cosine graph. So we're starting down. We also have an amplitude of 3, which means our starting point is down here at negative 3. So let's get those values in. Let's make our list. So we have minimum, because we're doing the negative cosine graph that I have right there. Then an intercept. Then a max. Then an intercept. And then a minimum. So it is going to be reversed of before. Our minimum value starts at 0. Our phase shift is none, which means we continue to remain at the beginning of the regular cycles for sine and cosine, which is 0. But this time we're going down to negative 3. Okay? Simply have to add 1, so that's 1. And then it's an intercept, 0. So your max, we're adding 1 again, is going to occur at 2, positive 3 for the amplitude, and then intercept, of course, 3, 0, and 4, negative 3. And the distance between the x on the min and the x on the initial value and the x on the end of the cycle value has a difference of 4. So we're good. So draw your points. There, 1, 2, 3, and we're going to stop. And remember that the graph does not end at the beginning and end of those cycles. It continues. So you need to make sure you show that and label your points. So hopefully these couple additional examples helped you in graphing your sine and cosine graphs.